Hi, welcome to Video Math Lessons. Tonight we're going to be doing a lesson on simplifying radicals. Here we go. So first off, when we start with radicals, we got to think about how do they want us to break down a radical. So usually they'll give us something like, let's say rad 50. So I'm going to start with radical 50. And in the past, this is review of geometry. Hopefully they told you to make a little chart. And so you make a list here of we want to make a list of perfect squares. And so either you can do it by memory, which you should be able to do these through memory, or you use the calculator and you complete the chart. So then we start with the chart. So x, and this would be x squared. So 1 squared is 1, 2 squared, 4, 3 squared, 9. So you should fill this chart out. So 16, 25, 36. And 12 squared is 144. So what we're going to do is we're going to use this chart to break down these radicals. So we're going to start off with number 1, and the direction on these things would just say simplify. And that's all they tell you. That's a lot of times in math, they'll just give you the one direction. They'll just say simplify. So what they want us to do is they want us to break this radical down. So what we're going to do is we're going to take this 50, and then now we're starting off with an easy one, but what if you had like no idea? So what you can do is you go like this. Well, let me take the 50, and if I look here on the chart, where does 50 fall? And hopefully you realize 50 starts right here. 50 would be right in between 49 and 64. Now your goal is to pull out a perfect square that's in 50. So if you start here from 50, you work up the chart this way, right? Going back up this number. So 49 doesn't go in there. You're looking for whoever goes in perfectly. And then hopefully you recognize 25 goes in there perfectly. So what we do is we write down, this would be the perfect, and then this would be non-perfect. And it's probably best to keep them in this order, just like that. So the perfect would be, well, 50, what goes in here nicely would be 25. So it would be 25. And what's left over? Well, what makes 50? So it's 25 times 2. And then finally, you actually do it. So the square root of 25 is 5. Left over, rad 2. And that is how you simplify a radical, 5 rad 2. So let's try another one. Let's say 48. So radical 48. Now, this is one of those that people kind of screw up a lot of times. Well, I look to see where does 48 fall on the chart, and 48 falls right here. All right, and so you got to work your way up. Now, what a lot of people do is this is what people do. They go like this. Well, I know 4 goes into 48, and it does. It does. Definitely 4 does go into 48. So they pull out the 4, and then they say, well, what does that make? I got 12. But the problem is you can break down 12 again. You can break down 12 again. And the 12 would be 4 and 3. Well, square root of 4 is 2. That's another 2. So that's a 2 times 2 radical 3. And eventually they come up with 4 rad 3. The only problem is people generally, they would stop here, not breaking down the 12. So if you follow this method, you go like this. All right, where is 48? Well, 48's over here after the 36. You work your way up, and then and most of the time you have a calculator if you're not good at figuring out what goes into what. And then you get to 16. 16 goes into 48. So to square it, so it's radical, perfect, non-perfect. A lot of times I'll say good, bad. Square root of 16 is 4, left over, rad 3. Which is the same answer. Now, this first method is good if you want to like chip away at something. If you get a really big number you don't know, you can just like chip away at it piece by piece by piece, and it'll work. Just be careful. Let's try another one. So let's do rad 72. Rad 72. radical 72. Well, let's see now. 72 is down here. So 72 fits on my list up here. And you work your way up, and remember, once again, you want perfect, non-perfect. Well, perfect in 72 actually is 36. So 36 times 2 is 72. My answer is 6 red 2. This is review of geometry. This should be not a surprise. This is straight up review from geometry. And in geometry too, you probably did questions that had coefficients out front, right? So you had a coefficient out front. So let's put a 5 on this one, and we'll do this, 5 and 24. And now, so 24 is my number. Well, now I'm way up here on the list, so that's actually pretty less things to go in there. And be careful. Some people will say, oh, break down 24, and then they'll go 2 times 12. Yeah, that's nice, but it has nothing to do with breaking down a radical. What you got to remember is this. I need to find what's perfect on this side, the x squared side that goes into 24. So I got perfect, non-perfect. So I look here. No. There's my number is a 4. So 4 times 6. Don't lose the 5. Bring down the 5. And then remember, this just means it's hooked up by multiplying, right? So it's just this times this times this. Square root of 4 is 2. So it's 5 times 2, rad 6. Final, 10 rad 6. So the coefficient out front, we just multiply. So it's nothing, to scare you. Let's try another one. 2 rad 128. So once you use the method, figure out what's perfect in radical 128 and see what goes in there. So if you work your way through the list, hopefully you came up with 64 and 64 times 2. Rad 64 is 8, and that's rad 2. And then, this is enough work. You don't have to go crazy. So if you want, you can bring it down, but this would be fine. If you get 2 times 8 is 16, left over, rad 2. Three radical 98. Nice and easy. 98 goes right here on the chart. And when you're doing these, especially when you're first learning, you should probably make a chart, every couple that you're doing, so you're not using the same chart. But, just make sure you know this chart. So 98, look on your list, see if you can break it down. And remember, you want good, bad, perfect square, non-perfect square. Working with the chart, hopefully 49 jumps out at you. So it's 49 and a 2. Square root of 49 is 7. And then remember, this is all hooked up by multiplying. 3 times 7 times rad 2 is 21 radical 2. Well, that's all from that's old. That's old stuff. How about some new stuff? And the new stuff would be variables. This part is probably new for you. Now, it depends on who your teacher was. They might have done some variables, but they probably didn't go crazy with the variables like we're going to. Now, the easiest one would be to say something like this. Square root of x squared. That's an easy one. And just about everybody would say x. Yes, congratulations. But what's going on with this? Like, what's going on? So what if I said, what's the square root of x to the 6? And then you guys say, well, what times what makes x to the 6? Let's call this problem 8. What times what makes x to the 6? And hopefully you can come up with x cubed. Well, there's got to be something going on here, and there is. For variables, so for variables. Even powers are perfect squares. That's the trick with variables. Even powers are perfect squares. Well, then how do you do it? Well, to take the square root, well, now look, this was a 2, now it's a 1. This was a 6, now it's a 3. What you do is you take half the power. Take half the power. So let's try it. Square root, and we'll put 2 letters this time. X to the 4, y to the 8. Now you say, look, are these perfect squares? And the rule is, for variables, even powers are perfect squares. So 4 is good, 8 is good. So now you just do it. So you get x squared, y4. What if they're not even? Okay, so what if they're not even? Well, you will fix it. That's horrible looking. You're going to fix it. So how do we fix it? Well, let's pick one, like x to the 5. X to the 5th power. Now, evens are perfect. This is an odd, so it's not perfect. So what you do is a little trick we do. You got to find the biggest even number that goes into 5. Well, x to the 4. That's the biggest even number. And what you really do is this. Just take off 1. That's a 5, you take off 1. So you put a 1 in the back. That's not perfect. x4 is perfect. So you get x squared radical x. Let's try it again. Do one more. Radical y to the 13th power. That's a 13 right there. Y to the 13th. 13's odd, not perfect. So what do we do? Well, look, I want to make this even, so you take off 1, so y1, left over y12, and then do what it says. So the final answer would be y to the 6, take half the power, radical y. That's pretty much basic review of how to simplify a radical. Well, that's it. Thank you for watching and paying attention. And yeah, I'll see you around.